And again, everyone, welcome to our webinar today, Streaming ETL for Data Lakes using Amazon Kinesis Firehose. Our presenter today is Ryan Nienhuis. Ryan is a Senior Product Manager with us at AWS, and we're excited to introduce him alongside our team of moderators. Today with us, we also have Kapil, Roy, and Alan, who will engage with you, as I mentioned, and answer all the questions you have. So keep them coming throughout the presentation as soon as they come up to you. So Ryan, the floor is now yours. Go ahead and begin.
Hi, everyone. My name is Ryan Nienhuis. I'm a Senior Product Manager for the Amazon Kinesis team. I've been working for the team for several years, and I'm excited to talk to you today about streaming ETL for data lakes using Amazon Kinesis Firehose. As we go through the presentation, I'd love for you guys to ask questions in the chat. We have got a lot of Kinesis experts on the line, ask everything from very simple questions to more complicated questions. We have the people there to complete your questions. So today we're going to provide an overview of data lakes, and we're going to talk about why customers use Kinesis Firehose to deliver data to their data lakes. I'll go through a demo of setting up a Firehose so that you can ingest data into real time, transform it, and then deliver it to Amazon S3, where you can use your existing analytics tools and batch processing tools to process the data in near real time. And we'll definitely leave some time for some Q&A after the presentation and the demo. With that, let's begin. So what capabilities are important to when you're building your data lake? So the first and sort of where you'd like to get started is collecting and storing data of any type at any scale and at low cost. So when we mean data at any type, data as you capture it is usually raw. It could be JSON data, CSV, protobuf, Avro, compressed data. It could be coming from user-generated sources like web clients, mobile phones, and mobile applications. It could be sensor-generated data, things like IoT, temperatures, smart cars, smart homes, smart buildings. And this data typically comes in very, very small with a large amount of varieties. When I say small, I mean the data at a typical event is usually less than 1 KB, but it's coming at a very high volume. So talking about hundreds or thousands or even millions of events per second that are being generated. And what you want to do is you want to get access to that data and store it in a centralized manner so that you can use a wide variety of tools to process that data. Another very important aspect of data lakes is securing and protecting the data, making sure that you have proper access controls in place, proper fine-grained controls for specific types of data, and that if it's data that has security controls such as healthcare, personal identifiable information or healthcare data, the data is encrypted where it's stored. So that's another very important aspect of data lakes. The data has to be readily available for your tools to easily discover it as well as process it and find the information that you need. So usually things like schema management systems, schema registries, metadata about the data needs to be visible and accessible to a large variety of tools. So very commonly, Hive is used for this. Another very common approach is to structure raw data from your data lake and get into databases where it's structured and much more easily discoverable. The other important aspect I've mentioned several times sort of during the other points, but you need to be able to quickly and easily perform new types of data analysis on data sets. So the previous first point and third point are very important to that. How you collect it, how the data is stored, if the data is clean, solving a lot of the problems that you don't want to have to solve the problem multiple times. So in that regard, you want your data to be stored, cleaned up in nice large files, even though the events are small, as well as easily discoverable by the tools that you use, be it a data warehouse like Amazon Redshift, or be it a query tooling on S3 like Amazon Athena. Another important aspect of data lakes are schema and schemaless. So there are use cases that you'll want a good defined schema. These are usually use cases that have a lot of business criticality to them. So they're not like ad hoc analysis. An example of this is when you're generating billing reports on your data lake, you'll want a lot of structure on the data to make sure that all the data is processed exactly once, and then you produce a clean and accurate bill for your customers. A different example of where that might not be as advantageous is something like ad hoc analysis. So using a key example is Amazon Athena on S3. So querying the data on S3, you don't necessarily need to apply that amount of rigidity to your data processing. So you want to do something what's called schema on read. This is taking sort of an unstructured data and as you query the data, applying sort of the structure to it as part of the querying process. So I provide an overview of what data lake capabilities are important. One of the thing that we're going to dive deep on today is how do you collect this information from this wide variety of sources in a wide variety of types at a large scale at a low cost, such that the last 4 items become a lot easier to accomplish. So Amazon S3 is a great general purpose storage that is highly scalable and durable that serves that need. If you're not familiar with Amazon S3, the service, you create buckets and you have objects in those buckets. You organize data either in like a folder structure or as you see fit. It's very highly flexible and highly scalable, which makes it well suited for data at any type, at any scale, and at a low cost. For data ingestion, a service that you may not be familiar with, but will be the focus of the talk today, is Amazon Kinesis Firehose. Amazon Kinesis Firehose is about real-time streaming, extract, transform, and load. Sometimes we like to call it ingest, transform, and load. It allows you to easily capture data as it occurs, buffer it into large, nice, clean files, transform it, and then load it to Amazon S3. Again, for any type of data, at any scale, and at low cost. The key problem that Amazon Kinesis Firehose solves is it buffers data and transforms it prior to delivering to S3. This is important because most processing tools are significantly more efficient operating on data S3 when the data is cleaned up, as well as when the data is in larger files, such that it can more efficiently process it. Having millions upon millions of files that are all of a small size is a very inefficient way to process data. Though some tools will do it, almost all tools typically perform better, as well as more easily work with data that's organized in a better fashion, as well as in larger files. So that is the key problem that Firehose helps solve. It captures these millions of small events in real time, buffers them, and then delivers them to a destination of your choice. I keep on using the phrase real time or near real time as we present this. And this is an important concept because another key aspect, value proposition of what Amazon Kinesis and specifically Amazon Kinesis Firehose provides is that it allows you to go from data to information very, very quickly. And the value of that data is much more quickly versus historic. A very simple example of this is your monthly business report that you produced this month is obviously more valuable than the report that was produced over a year ago. Closer to more real time, if you can detect that a customer is having an issue and react to it as the issue is occurring, that's much better than retroactively discovering that several of your customers ran into a bug and getting transparency into that issue a day, a week, or even several weeks later. So we like to talk about the time value of data in this regard. You want to get that data into your data lake as quickly as possible, but not sacrificing the tenets that I brought up in the beginning of the call. That needs to be easily discoverable. A lot of tools need to access on it, and you need to handle a very large variety of that data. So Amazon Kinesis Firehose is all about capturing data as it's been generated, transforming it, and then delivering it to a destination of your choice. To double down a little bit on what I mean by transform, and actually what I mean on each one of those steps. Let's start with capture and submit. So Amazon Kinesis is and Amazon Kinesis Firehose is a highly scalable way to write data to AWS that occurs in that the small pieces of high volume that I mentioned in the beginning of the call. As a good example of this, if you have tens of thousands, hundreds of thousands, or even millions of mobile app users, if you want to get that data delivered to them, there's two ways to do it. You can write it as it occurs using a service like Amazon Kinesis Firehose, which supports very, very high volume writes, or you can buffer data locally on that mobile app for maybe a couple seconds, maybe a couple hours, maybe even a day, and then write batch writes to a destination like Amazon S3 or some other general purpose storage solution. There's obvious advantages to doing it in real time, as I mentioned on the last slide. And Firehose allows a very easy way to solve that problem. You don't have to run a large number of your own instances to collect this information. You simply configure your devices or servers or sensors or whatever your data producers might be to write to Kinesis Firehose in a high volume, highly scalable way. Transform. Kinesis Firehose allows you to transform the data before it delivers to your data lake in S3, your data warehouse in Amazon Redshift, or the Amazon Elasticsearch service. The type of transformation it does can be very, very simple, just buffers, where you configure the size of data you want to deliver. So I want my files to be chunked in 1 megabyte, 10 megabytes, and as well as time. So I want to deliver files every 10 seconds, every 60 seconds, every 5 minutes, so on and so forth. That's the simplest transformation you can perform. But Kinesis Firehose supports much more. In addition to that type of transformation, you can also compress the data before it's delivered, encrypt the data before it's delivered, as well as perform more complex transformations using AWS Lambda to transform those records, record by record, prior to its delivery. So essentially, you get a serverless, near real-time delivery of data into your data lake with the data transformed, cleaned up, and ready to go to be processed by your analytics tools. Kinesis Firehose has a wide variety of customers. To highlight two of them, Hello and Realtor.com. Hello is a company that uses cloud technology to basically deliver personalized solutions to customers. Their first product is a sleep monitoring device that allows you to get your best rest. What they use is they collect this user data using Amazon Kinesis Firehose in real time, process that data in near real time, such that they can provide their users with the real-time or near real-time feedback about their sleep patterns as it occurs. So imagine waking up and seeing information about how much sleep you had, and ways you could improve it. Hello provides that. Realtor.com is another interesting use case in which they serve ad impressions to their customers, and they're basically tracking the performance of an ad in real time. So as customers browse their website, they may be giving recommendations to them, as well as other clickstream-like events, and they want to get visibility into what's going on right now. They use Amazon Kinesis Firehose to deliver data to Amazon S3 into their data lake, as well as Amazon Redshift. So I'm going to highlight a couple of use cases and sort of patterns using Amazon Kinesis Firehose. The first pattern will be the pattern that we're going to focus on today, and the one that I'll give a demo of later in the presentation. It's getting data from a data source, doing high volume puts from a large number of data sources to Firehose, storing the raw records, just simply buffered into larger files, into a backup S3 bucket. In addition to that, delivering the data to S3, transformed. So a good example of this is you have a clickstream event from a mobile app or a website, and you want to augment that data. Maybe you have a user ID that you want to augment with more customer metadata before you deliver it to S3. You would write the data to a Firehose delivery stream. As part of that delivery stream, you'll use AWS Lambda to transform those records and enrich them with metadata about the customer to make it more easily discoverable, to improve your time from data to information, and then deliver those transformed records to Amazon S3 in a logically organized format that allows you to use your analytics tools more easily. A similar pattern for this is to deliver data to your data warehouse, Amazon Redshift. Amazon Redshift is a columnar database that scales to petabytes of data that allows you to easily query and find out information about your business, both for near real time using Amazon Kinesis Firehose, as well as historical data. So in this similar case, we transform the records, maybe we do an enrichment, and then we load data into Redshift in the best practice recommended way. And what that is basically Amazon Kinesis Firehose and the delivery stream will manage writing data to S3 and then doing bulk copies of that data from Amazon S3 to Amazon Redshift. The net benefit is in less than a minute, depending on your configuration, less than a minute, maybe a couple minutes, you get a nice, clean, queryable data in various tables in your Redshift cluster. So imagine removing all of the ETL you have prior to your databases, or in this case, Amazon Redshift, and replacing that with a managed pipeline that transforms the data and takes you from data to information in a matter of minutes instead of a matter of hours or days. That's the power of what Kinesis Firehose provides. Finally, another very popular destination for Amazon Kinesis Firehose is the Amazon Elasticsearch cluster. This data is typically more real-time. Customers use Amazon Elasticsearch for doing querying and searching the possibly log data over the last 7 days or over the last day. We're doing ad hoc analysis on operational events to drive business dashboards that are near real-time business dashboards that help customers visualize what's going on in their business. A key part of Elasticsearch operates a lot better, similar to a data lake, when the data is transformed prior to delivery. Firehose provides that ability to deliver that in a highly efficient manner to your Elasticsearch clusters. I won't focus too much on this use case in particular because I would like to show the demo on the data lake delivery solution. But it's another valuable thing you can do with Amazon Kinesis Firehose. So now we're going to transition to the demo and walkthrough. I recorded this ahead of time last week. The whole solution, you'll see me go through it. It took about less than 10 minutes. And I used a variety of sort of tools to help sample. But I encourage you after this presentation to go through this today. The slides that we'll be sharing will actually have step-by-step guide, as well as you can go to the Amazon Kinesis Firehose documentation and just walk through a simple example. What I'm going to demo today is delivering data to your data lake in Amazon S3 and transforming that data using AWS Lambda prior to the delivery. So I'm going to walk through the creation of a Kinesis Firehose, the associated S3 buckets, and then showing the data flow through the system, going from raw Apache log access logs to transform logs in CSV format. So very simple transformation, but it gives you an idea of what you can accomplish using the service. And as I do this, imagine that you have are continuously writing to Kinesis Firehose in real time from your Amazon EC2 instances. And imagine you have hundreds or tens of thousands of them. Kinesis Firehose scales elastically without any intervention on your part. So you'll see the amount of throughput that I put through the system without any setup on my end. So with that, let's go ahead and get started. So Kinesis is under the analytics section of the AWS Management Console. Amazon Kinesis has 3 different capabilities. We're focusing on Firehose today. Kinesis Streams allows you to build custom applications that process data in real time. Kinesis Analytics allows you to continuously run SQL queries on your streaming data. either from Kinesis streams or from Firehose, again in real time. Firehose specifically, as I mentioned before, is about capturing, transform, and loading your streaming data into, say, a data lake or a data warehouse. So I'm going to go ahead and choose Amazon, go to the Firehose console. I already have a delivery stream set up here, but I'm going to go ahead and create a brand new one. The first thing I'm going to do is select a destination. And I'm going to choose Amazon S3 and then provide a name. After I provide a name for my delivery stream, I'm going to create a new S3 bucket. I'm operating in Oregon, so I'm going to select the region, Oregon region. So Kinesis Firehose allows you to specify a prefix for your S3 bucket. If you're not familiar with S3, you can think of this as sort of a top-level folder structure. As it saves data to S3, I'll show you, but it basically segments out data and partitions it in a time-based format. So year, 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 month, month, day, day, hour, hour. And I'll show this after we start getting data flowing through the delivery stream and delivering it to Amazon S3. So here are a bunch of configurations. Here's where you specify the transformations. I'm going to enable the transformations. I have a couple of Lambda functions that I already have set up, but I'm going to go ahead and create a new one. We have some templates that you can use that transform, say, Apache logs to JSON or CSV, but you can do any type of processing you can do in Lambda as part of the delivery. Some customers do even more than transform. For example, we have customers that will deliver data to DynamoDB or other databases as part of this, maybe a filtered set, as well as deliver the data to Amazon S3. So we start with the Lambda function code. I'm going to go to Notepad and copy and paste the code that to transform an Apache log to a CSV file. I'm going to pause it real quick. I highlighted the callback there. Rewind it a little bit. I missed it, but I highlighted the callback there. The way the Firehose delivery stream invokes the Lambda function is it receives your data that you write from your devices or your EC2 instances, or whatever your data producers might be. It invokes the Lambda function with basically a set of records. So this might, depending on your throughput, this might be 10 records, this might be 5,000 records. Those records are then transformed by your own code. You can do any type of transformation, as I mentioned before, and then you pass back the transformed records. So that's sort of the signature, the interface that you pass back for us to deliver data to your destination. I pick the appropriate role. There are some advanced settings, such as a timeout, how much compute you want to use in the Lambda function, but those are things you can work with after you initially create the function. I'm going to refresh the list and go to the Lambda function that I just created. Here we have a warning that basically says your Lambda function is only 3 seconds. If we pass you 5,000 records, for example, to process and transform, that might not be enough time. So we recommend a timeout of about 1 minute as a starting point before you start testing and building the type of transformation code that you want. So I'm going to save that. Go back to my Firehose delivery stream creation page and my various configurations. You'll see the Lambda function timeout is now 1 minute. Here's a set of other options for delivering data to S3. There's the buffer size, so how large of files do you want? And the buffering interval, at what interval do we want to deliver data to? Kinesis Firehose will buffer these transform records based off of these configurations of whatever hit first. So if we hit the buffer size first, we'll deliver the data. If we hit the buffer interval or the time limit, we'll deliver the data then. We also have options to do data compression. So gzip, zip, or snappy, as well as data encryption. The last point that I didn't mouse over was the error logging. So Amazon Kinesis Firehose manages a lot for you, but you really want to get visibility into, say you have an error loading into your data lake, or you have an error load, an IAM role permission issue for delivering data, or the bucket was deleted, or something along those lines. Amazon Kinesis Firehose integrates with CloudWatch logs to provide you visibility into those type of errors so you can diagnose and fix them in real time. And no matter what happens, Kinesis Firehose will always back up your raw data somewhere, such that if you have an issue, we'll make sure that data is not lost. So the last step I'm going through is sort of the IAM role creation. So I did that. I'm just using the standard default role. Click next. So my configuration is all set up. I'm ready to go. Let's start writing data to it. I'm going to create my delivery stream. You see it's in creation. And it takes a small amount of time to go through creation. So while that occurs, I'm going to show you sort of other parts of the solution. This is what the raw data looks like that I'm sending to. It's a standard extended log format, W3C log format, Apache logs. You can see the IP address, the date time, the type of request it was, and information about the user agent, so on and so forth. We're going to transform this data, perform a very simple transform to basically, instead of it being in this format, to be it being in CSV format. So we have this tool we released a couple months ago. It's called the Kinesis Data Generator. It basically is a good testing and development tool. It allows you to mock data and send to Amazon Kinesis streams, as well as in this case, Amazon Kinesis Firehose delivery streams. So I'm going to write to the Firehose I just created, the data lake demo, and I'm going to specify the rate in which I want to write records. And I want to give a little bit of oomph, so I'm going to choose 1,500 records per second. And you see we have these templates. So this will automatically generate dynamic Apache logs for you to test the solution with. This is an open source solution that's available on GitHub. I use it very frequently to test Amazon Kinesis Streams, Firehose, and analytics. It's a very useful tool. It allows me to test my template. You can see the Apache logs are being generated. Once I'm happy with the dynamic data that's being generated, I'm going to click Send Data to Kinesis. And it's just going to start pump very efficiently from your browser, basically just pumping data into your Firehose delivery stream. It's a good tool to get started as well as test out specific types of use cases. The transformation and the Lambda function that I configured is going to do this. As you can see, this is actually an old file that I had from doing a similar demo. This is exactly how the data shows up in S3. So you can see that it's transformed into a comma-separated file. You could imagine transforming into JSON data or other types of formats, depending on how you want to store the data in your data lake. As always, we deliver the raw data to S3 as well. We give you that option. So if you also want to store the raw data with the transform data, in case your function code didn't behave in the expected manner that you want to, we provide you that ability. So my delivery stream is now active. I'm going to go to the S3 bucket. And we're going to show you the data is arriving already. The transform data is arriving already. We talked about the time value of data in the beginning of the presentation. This is exactly what I'm talking about. This is immediately available for you to query using Amazon Athena. It's also available for you to run, say, Spark on, or any one of the tools in the Hadoop ecosystem, as well as other BI tools and batch processing tools of your choice. And it's available in a matter of seconds. I had the configuration set fairly tiny, so like 1 megabyte files, 60 seconds, the lowest end of the sort of configuration. But you can deliver much larger files, so 10 megabytes, so on and so forth, 50 megabytes. and increase that time so that you operate on much larger files. It really gives you the choice to make a decision based off of, do you want data to arrive sooner to lower your latency, or do you want data to arrive in much bigger files that you can work with more easily? It gives you the control. So here I'm showing the transform record that I just downloaded from S3, similar to the previous file that I showed you before. And you notice that the folder structure, or the how I partition the data in Amazon S3 is in that year, month, day, hour format that I specified previously. So I'm going to go to the CloudWatch dashboard just to show some of the early monitoring that appears for this delivery stream. And I'm going to pick one of the metrics I like to monitor for these delivery streams are incoming records. And the other thing that I like to measure is records that were delivered to S3 successfully. So delivered to S3.records. We do this per destination, so you can get visibility into any issues either on the receipt of information from your data producers or on the delivery of those. I'm going to choose sum, which gives you the total metrics, and I'm going to choose 1 minute. There's a large number of other metrics that you can use to sort of monitor what's going on in your pipeline to S3. I chose 2 obvious ones, but a lot of them are like, were you successful in delivering, things that you can easily set up alarms on to if you have any issues with your delivery process. And again, as I mentioned, CloudWatch, we also integrate with CloudWatch logs to provide more detailed monitoring. So here's a delivery stream that I was testing earlier in the day prior to this demo, showing how many records I've delivered to S3. And all I did was just keep that data generator running. And you can see over time that I'm delivering quite literally millions upon millions of records over the course of the day. And we have customers that deliver billions or even trillions of records per day using Amazon Kinesis Firehose and their delivery streams to S3. So that's the end of my demo. I have a couple more slides and then we'll open it up to questions. So as I mentioned, the slides had sort of a step-by-step guide of going through this. Here's what the monitoring dashboard would look like if you had the Firehose delivery stream running. This is the Firehose console. There's the details tab, which shows you your various configurations, allows you to edit them, change your transformation logic, perhaps changing how long we're buffering data. This is the monitoring tab on the Kinesis Firehose dashboard that shows you some of the most important metrics about us delivering your data to Amazon S3. This is an example of the CloudWatch logs that I mentioned a couple times, where the bucket was deleted or was removed, or something went wrong with the configuration, us providing you visibility that we're trying to deliver the data to your S3 bucket, but it no longer doesn't look like it exists. So pricing. So Kinesis Firehose actually just recently released a price reduction last month. So your first 500 terabytes of data per month, we charge 2.9 cents per gigabyte. And then there's tiered pricing. It continues to get cheaper the more data that's sent. So the more you use the service, the cheaper it becomes per gigabyte. We talked about in the beginning of the presentation about we want to deliver this data in near real time to your data lakes, but we need to do so cost effectively. And Kinesis Firehose provides a very low cost as well as low total cost of ownership for delivering your data and transforming it, doing streaming ETL into your data lake based on Amazon S3. When we say low total cost of ownership, specifically what I mean is I did just show a very simple example, but you see that the setup and monitoring and just general maintenance of this end-to-end solution is relatively trivial in comparison to, say, manage your own batch ETL project. And it comes up with other advantages such as your time to information is much faster. So when we talk with customers, those are typically the two things that they like most about Kinesis Firehose. The low cost, as well as low cost of total cost of ownership, as well as the fact that they have access to their data using the processing analytics tools that they're familiar with in very, very quickly, in minutes, as opposed to hours, days, or even